Welcome to Ask and Learn.
We want to sketch the curve y is equal to x to the fifth minus 5x. So in this chapter, they give us this laundry list of steps we should follow if we want to sketch a graph of some function. So let's just go ahead and follow those steps. So the first thing they tell us to find is our domain of the function. Well, this is a polynomial, and we know polynomials have a domain of all real numbers. So all real numbers or negative infinity to infinity. The next thing they suggest we find is our intercepts. So let's go ahead and do that. So our y-intercept, actually let me go ahead and write that below down here. So our y-intercept will be when x is equal to 0. So y is going to be 0 to the fifth minus 5 times 0, which is just 0. And then to find our x-intercepts, remember we're going to set y equal to 0, so we get 0 is equal to x to the fifth minus 5x. And we can go ahead and factor this, and we will get 0 is equal to x to the fourth minus 5. And using the zero product property, we get x is equal to 0, or x is equal to plus or minus the fourth root of 5. And this here is approximately 1.5. And we'll just need to know that approximation for later. The last thing they want us to check is for symmetry. So this won't be a periodic function, but we can check to see if it's going to be even or odd. So we want to check f of negative x, and doing that, we will get, well, negative x to the fifth power, or actually, let me just go ahead and write out negative x to the fifth minus 5 minus x. Well, we can go ahead and pull that negative out to the fifth power, since it would be negative 1 to the fifth. So that should be negative x to the fifth, and then those two negatives there cancel out. And now notice, if we factor that negative out, we get x to the fifth minus 5x, and this here is negative f of x. So what this implies is that we have a odd function or symmetry about origin. Oh, origin, let me spell that correctly. Origin. All right. Next, they suggest we find any asymptotes. Well, we know that since this is a polynomial, there should be no asymptotes, but we can use similar logic to figure out what our end behavior of this graph should be. So I'm going to go ahead and call this f of x. So as x goes to infinity, well, this is an odd function with a positive coefficient, so we know this should go to infinity. And with it being a odd degree polynomial, then it should have the opposite end behavior for negative infinity. So it would go to negative infinity as x goes to negative infinity. So the next two steps I'm going to combine into one, and this was supposed to be looking for intervals where it increases, decreases, and we're going to look for local maxes and mins. So that means we want to figure out what y prime is and then set it bigger than 0 and less than 0. Right, so taking the derivative of x to the fifth, well, we're going to use power rule to take the derivative of each of these. So we're going to get 5x to the fourth minus 5. Now, we want to figure out where, or actually, so before we do that, let's go ahead and set this equal to 0 so we can find our critical points. So setting this equal to 0, we would divide by 5 and we get x to the fourth minus 1 is equal to 0. And then that would tell us x is just going to be plus or minus 1 once we go ahead and move the 1 over and take the fourth root of 1. All right, and actually let me go ahead and write that out as x is equal to negative 1 and x is equal to 1. Now, what we want to do is figure out where it is increasing or decreasing. So y prime is going to be larger than 0. So just for brevity of the problem, I went ahead and already solved this. So this inequality will hold on negative infinity to negative 1. And 1 to infinity. So remember, this here tells us it is increasing. Next, we want to find where the function is decreasing, which would be when y prime is strictly less than 0. So this is decreasing. And again, I already went ahead and solved this, and it should just be negative 1 to 1. All right, so on negative 1 to 1, we know our function is going to be decreasing. So over here, I'm just going to go ahead and write this. So it's decreasing from negative 1 to 1, and it would be increasing before negative 1 and increasing after 1. So that's telling us that x is equal to 1 is a minimum, and x is equal to negative 1 has a maximum. Remember, both of these being local. All right. Next, it says we want to determine the concavity and points of inflection. So concavity and inflection points. So this means we're going to want to look at the second derivative. So y double prime, well, this is going to be the derivative with respect to x of our first derivative, which is 5x to the fourth minus 5. So once again, to take the derivative of x to the fourth, it's power rule. So we get 5 times 4, 20 times x to the third power. And then the derivative of 5 is just 0. And let's go ahead and set this equal to 0 and solve for that really quickly. So 0, well, that's just going to be x is equal to 0. Now we can go ahead and do the same thing and look for where y double prime is larger than 0, which would tell us our function is concave up there. And then look for where y double prime is less than 0, which would be concave down. So y double prime larger than 0. Well, x cubed is going to be larger than 0 on 0 to infinity, or 20x cubed, I should say. And then it will be strictly less than 0 on negative infinity to 0. So to the left of 0, this function is concave down, and to the right, it's concave up. So that tells us x is equal to 0 should be a inflection point of our graph. So we followed all of these steps that they suggested we do before we start actually trying to graph this. So let's first go ahead and just plot down our intercepts. So we have the intercept 0, 0. And we have, and actually before we do that, we know that this should be an odd function from step 3. So all I'm going to do is I'm going to only graph the left side of this. And by only graphing the left side, I would know I would just reflect whatever I did on the left over to the right. All right. So we will, or not reflected over to the right, but reflected across the origin or the line y is equal to x. So on the left side, we would just have 1, 0, which is going to be negative fourth root of 5. And what other things on the left do we have? So we know from step 4 that our end behavior should be going to negative infinity. And we know that we have a local max at x is equal to negative 1. So negative 1 will be right here, and we know this should be a max. All right, so that should be everything for the left side of this function. Now let's just go ahead and start graphing. So our first point of importance is going to be our 0 here at negative fourth root of 5. And then after that, we know we're going to have a maximum around here somewhere. So let me actually do that in a different color. So we're going to have a maximum maybe around here. And then it keeps on going up. Then the next thing we're of interest is our point of inflection at x is equal to 0. So at this point, we need to make sure that it's going from concave up to concave up. It should be concave down, so really stress that here, and then on the other side it should start to be concave up. And now that we have this symmetry, let's just go ahead and put in the line y is equal to x, and now we're just going to reflect everything across, or not y is equal to x, sorry, we're just going to flip everything across the origin now. So instead of being a maximum at 1, it's going to now be a minimum. So we just go over here, put our maximum, and then after this, it's going to just go up until it crosses the x-axis again, like that. So you could have went ahead and plotted in all the other points, but for this side here, I'm just using the fact from number 3 that we know this is an odd function with symmetry about the origin.